Students, coming to the next topic, that is BFS. So this is one of the graph traversal techniques. Many graph problems solved by using some search methods. So let me explain first that basic thing. After that, I'll explain what is BFS. So many graphs, whatever the graph model you have taken, so that many graph problems solved using search methods. So we solve all the graph problems that are occurred that can be solved by using some search methods. So a path that may be like a path from one vertex to another, means by searching from one vertex to another, or is the graph connected, is the graph connected, or else by finding the spanning tree, finding a spanning tree, etc. So there are so many methods, search methods to solve a graph problem. Okay, so the main commonly used search methods are commonly used search methods. So what are the most commonly used search methods? So those are BFS and DFS. So these are the main searching methods to solve the graph problems. So by using breadth first search and by using depth first search. Now let us see what is the breadth first search. We will discuss what is BFS in this video. So let me write BFS, breadth first search. So what we are going to do in this search algorithm. So the first thing is, whatever the graph you have taken, the graph consists of some edges and vertices. So first visit start vertex and put into a queue. That is by using FIFO, first in first out. So actually the main thing, the difference here is the breadth first search always uses queue, whereas depth first search uses the stack operations. Means it performs the stack operations, and whereas the breadth first search uses the FIFO. This is FIFO and the BFS is LIFO. Okay. So here we are discussing BFS. So first visit the start vertex and put into a queue. So after that, you have to repeatedly remove a vertex from queue. So whatever the data that you insert in the queue, that has to be removed whenever that all adjacent vertices are visited. Means whenever that vertex work is over, means if it visit all the vertices, then you just remove that vertex from the queue. Okay, so repeatedly remove a vertex from queue, visits its unvisited adjacent vertices, okay, and put newly visited vertices into the queue. So this is a process how we are just inserting the values and just removing the values. Okay, I'll explain clearly by the help of the algorithm and the example. Don't be confused. So let me write the pseudocode for the BFS. So mostly you'll understand what is BFS in this pseudocode, or else I'll take the example to understand the breadth first search. So what is the pseudocode for this? First you have to write the procedure breadth first search. So the input for the breadth first search is just a graph. You have to give the graph. So in that we have to find every vertex by using the search algorithm. So procedure is breadth first search. The input for the breadth first search is just a graph G. and you are taking a queue to insert the values vertices in the queue. So Q, letter Q. Next, let us take the integers s and x. Okay, I'm taking two integers s and x. Now, while G is a graph, G has an unvisited node. If suppose the graph is having unvisited node, then do S is equal to an unvisited node. Means now you are entering into an unvisited node. Okay, so this is S now. This is an unvisited node. So if G, the graph, has an unvisited node, then you place this unvisited node, assign this unvisited node to S, and you have to visit that. Visit S. Means you have to enqueue. Enqueue means putting the value in the queue. So Q is this a queue. Let us take the queue like this. Okay, Q, just visit that node. That is the B, the value. Means let's take the S, this is. Okay. So first you have to check G has unvisited node or not. If G has unvisited node, then you have to mark that unvisited node to visit. Okay, so whenever it visit, it has to enter into the queue. So that value should be entered into the queue, that is the enqueue. Okay, so after that, again check while queue is not empty. Suppose the queue, whatever that is, the queue is not empty, it is having some values A, B, C, D, E, like that. Means if the queue is not empty, then what I have to do? I have to dequeue it. X is equal to dq. Dq of q means you are just remove the elements from the list, the first in first out. For unvisited neighbors y of x, do visit y nq y comma q. Okay, so just whatever the adjacent values you vertices you visited, so that visited vertex, if that vertex doesn't have any remaining vertices to be visited, then just remove that element from the queue. Just remove that element from the queue. So this is just a pseudocode for the queue, BFS. Now let me take the example. Then you will clearly understand what is this BFS. So that example I explain in the next video. Thank you.